Assalamualaikum and good day everyone. This is chapter 5, gravity retaining wall. Firstly, you have to know what is gravity retaining wall. Any structure that is constructed on the surface of the earth will be pulled toward the earth center. Anything any structure, so maksudnya apa-apa je because of ada downward acting force yang dipanggil weight of the structure, and also ada gravity acceleration. So when a structure is almost or entirely dependent upon its weight for stability, it may be termed as gravity dependent structure. This is the example of gravity retaining wall. One here you have something that we call it creep wall, and this is gabion wall. There are so many types of wall, but the one that we're going to learn is the masonry wall and also brick wall, reinforced concrete wall. But that one doesn't matter because we're just going to calculate based on the weight of the structure. We need to know what is the failure criteria of retaining wall. It occurs when one of several limit state is exceed. Therefore, factor of safety for each of these limits must be determined. Dia ada limit state maksudnya dia ada factor of safety. Let's say the value yang you dapat nanti, because you need to calculate the factor of safety. Berapa factor of safety daripada the calculation of force yang pull you punya retaining wall and force yang stabilizekan you punya retaining wall. So berapa you have to calculate that, then you will dapat the factor of safety. From this factor of safety, you kena compare dengan factor of safety berapa yang selamat. For example, 2.5. So let's say you dapat less than 2.5 means wall tu tak selamat. There are 5 limit states: overturning, tension in the joints, bearing on the ground, sliding along the base, and rotational slip. So we're going to look at one by one. So we have overturning. The wall will overturn by rotating some point near the toe. Kat sini if overturning moment of the lateral force, this is lateral force, is greater than the stabilized moment of weight of the wall. This is what will happen. We have toe and heel. For toe, saya panggil dia A. For heel, we call it B. Dia akan rotate dekat A, means kat belakang ni ialah you punya retain material. Anything that you retain, for example, if you retain water, soil, so it's going to be at the back here. A mesti yang dekat depan lah, meaning we call it as toe, and B is heel. Let's say force here is too much. You know that from force will turn into moment. When force here is too much, it's bigger than the stabilizing moment. Maksudnya kat bawah ni pun ada force juga, because force daripada you punya weight of the wall. Weight of the wall punya ada force. One dia akan pergi arah sini, and another one dia akan pergi macam ni lah. Dia berlawan. This one is bigger, so your wall will overturn sebab dia tak mampu, dia kan melawan. Dia tak mampu nak stabilizekan you punya retaining wall, so your wall will overturn. Factor of safety against overturning is at least 2. FS lah kita panggil. FS is at least 2 Kalau less than 2, perhaps you dapat 1.8, 1.9, meaning your wall will overturn. Next is tension in a joint. If the wall is considered as a vertical cantilever. Okay, so you look at gambar kat bawah ni. Wall is considered as vertical cantilever BC. Superimposed upon the compressive stress induced in the horizontal joint. So horizontal meaning wall ni panjang lah arah sana kan. Tak kisahlah berapa panjang dia. Upon the compressive stress induced the horizontal joint due to the weight of the wall. Kan ada weight of the wall Akan ada bending stress which will tensile along BC. Okay, you have force here. Okay, so kat sini akan ada bending stress. You punya wall akan jadi macam mana? Okay, ada force macam tu. You punya wall akan terangkat meaning to say dia akan lifted a little bit like this. And also in brick or masonry wall, this tension may have effect on the opening of joints. This turn may lead to deterioration of the wall fabric. Bila ada forces acting on at the back of the wall here, kan belakang ni akan ada bending stress. Inside here, brickwork atau masonry wall, because you pakai brick kan, or masonry. So you akan join it together pakai mortar. Bila you join it together, force ni dia akan deteriorate kan, sebab you punya retaining wall mesti ada opening. Contohnya you letak piping dekat dalam ni lah. Piping untuk water. Kan you selalu nampak kan retaining wall kalau kat tepi-tepi highway, tepi jalan tu. So normally dia akan ada lubang-lubang kat situ. Okay, so this one adalah untuk water seepage. Nak elakkan water seepage so that air akan turun masuk dalam ni. Dia turun lah. So bawah ni ada longkang lah. So tu biasanya. Sorry, the retaining wall will easily deteriorate because of other force. This one yang acting on retaining wall you. And then you ada opening yang ada sambungan-sambungan. Masonry wall you pun bersambung using mortar and so on. So it will lead to deterioration of the wall fabric. And we have bearing on the ground. So the combination of downward acting weight, kat sini ada downward acting weight of the wall and overturning moment will set up a bearing pressure between the base and the ground. The maximum ground bearing pressure occurs beneath tooth. Failure will occur if applied pressure exceeds the ultimate bearing capacity. You must make sure bearing stress ni is actually stress dekat anything yang connect together. Maksudnya surface tu, for example, retaining wall and soil, dia akan ada bearing stress. Force daripada the back and also downward weight ni will produce bearing pressure. Okay, because of the force kat sini, so kat bawah ni in pressure. Bearing pressure produced by these two forces ni must not exceed the ultimate bearing capacity of the soil. Soil ni boleh support as much as 200 kN per meter square. Banyak ni je. Okay, kalau lebih daripada value ni, bearing pressure produced by the retaining wall exceed this one, meaning this what will happen lah. It will be failed. Because of pressure daripada retaining wall you akan transfer pada soil. So kalau soil you tak mampu support, so this what will happen. And then we have sliding. If the underside of the wall was smooth and it rests on a smooth surface. Bawah ni lah. Okay, smooth je. The wall slide easily along its base. So wall ni akan slide. Okay, macam mana dia slide? Okay, you ada letak force dekat situ, or we call it pressure here. Wall you akan slide. The wall only slide if the lateral face exceed the frictional resistance. RC here is frictional resistance. Kalau P more than RC, so akan jadi slide. We have a rotational slip. The wall with large amount of the retained mat. Retained mat ni maksudnya tanah Okay, yang you tahan dekat belakang ni. We rotate at center of O sini So ini adalah center of O. If the total moment of the weight of the wall W1 and soil mass ABC, A, B and C exceed the moment of shearing resistance developed along the circular AC. Maksudnya sekarang ni you punya retain mat ni terlampau banyak. Ini akan jadi. Dia akan rotate dekat center O. So you punya wall akan tilt ke belakang because of tanah yang dekat sini dia dah terlebih, so dia akan slip, so dia akan rotate dekat center of O. Ni jangan confuse lah. B ni maksudnya bukan B toe and heel ini masih toe and masih heel. So B ni kat sini maksudnya dia nak tunjukkan tanah tu kat mana, A, B and C. Going to look at the lateral pressure and thrust. Lateral force must be resisted by retaining or similar structure. May result from when you have liquid, you have retained granular material. Retained granular material sebenarnya soil lah. Angin, air and soil. Tak semestinya air, liquid can be anything kan, but we call it liquid lah. But normally air lah, dam. Okay, first we look at the wind pressure. The intensity of wind pressure against the side of the structure depends on many factors. For example, average wind velocity, amount of frequency, blah, 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 blah. So there are so many factors contribute to how you going to calculate the intensity of wind pressure. But because it's so hard for you to calculate because there are so many factors, so normally what we're going to do, we're just going to assume it to be uniform. When I say uniform, maksudnya, for example, you have your retaining wall here. For example, retaining wall ni cross section dia macam ni lah. Uniform ni. Tolong lukis supaya you faham benda ni. Daripada top sampai bottom uniform. For example, 10 Newton per meter square. Sama lah daripada atas sampai bawah. P is unit wind pressure. Satu ni sebab uniform so darab 1. H ni height of the wall. Kalau heightnya 3 meter then it is 3 meter lah. Because kita assume dia sama for the all height of the wall. A vertical wall of height 3 meters is subject to uniform horizontal wind pressure of 1.2. So this is small p. So jangan confuse because here tadi you nampak ada big P and small p. So big P is wind pressure. Small p is unit wind pressure. Untuk 1 meter square berapa Newton? Itu maksud dia. And then determine the magnitude and position of the resultant truss per meter length of the wall. You have this formula. 1.2 kilonewton per meter square ni dia punya unit pressure dia. Okay, maksudnya setiap 1 meter square 1.2 kilonewton intensity. Darab dengan 3 meters the height of the wall. So you dapat 3.6. For every 1 meter length of retaining wall, it is 3.6 kilonewton. Retaining wall macam ni tadi. So untuk setiap 1 meter 3.6 kilonewton. Dia punya wind pressure. Position of the resultant truss, I sebelum ni explain kan. Because of it's going to be uniform. Position that we're going to take at the punya center. Okay, so center dia going to be here lah, betul-betul tengah-tengah. Bila tengah-tengah, 1/2 darab dengan H. You dapat H over 2 lah. 3 meter height divided by 2 dapat 1.5 meter from the bottom of the retaining wall. Liquid pressure. Dam and other retaining structure are required to sustain a lateral thrust from the retained leaf. Earth retaining wall may also be resist hydrostatic pressure due to groundwater because of dalam tanah ada groundwater juga. But this one kita akan kira later lah groundwater punya sebab. Tapi whatever in liquid pressure that we calculate here, let's say you retain water. For example, yang duduk belakang retaining wall dulu lah. Contohnya macam dam or any other retaining structure yang retain liquid. To principle of hydrostatic, the pressure at any point of the liquid act uniformly in all direction. You ada liquid droplets here, the act semua sama. So the pressure acting at depth H below the surface of liquid is equal to the product of weight per unit volume of the liquid at the depth. The formula here, so P here means liquid pressure. P ni any pressure lah sebenarnya. Sebab you calculate pressure kan. For this formula lah untuk calculate liquid pressure. How dia dapat formula macam ni? This is your retaining wall. So it retain water at the back. This is dam lah. Dia punya pressure distribution going to be like this. Increase uniformly. You menyelam. You buatlah scuba diving. As the depth increase, the pressure also increase. And we going to assume it increase uniformly. Sebenarnya, value yang dekat bawah ni, berapa pressure yang dekat bawah sekali ni, pressure dia, how you going to calculate? PW darab G darab H. So this is the value of pressure dekat bawah ni. This is not PW, this is density of water. Atau unit of water darab dengan H. Bila you nak kira dia punya total pressure dia semua, the whole this thing, so you kena kira dia punya area. Value dekat sini is density of water darab G darab H. Ataupun unit weight of water darab H. Why half? Because of this is rectangle. You're going to calculate the area. Half times density of water times gravity acceleration and times H. So this is H. That's why darab H. Macam you kira area lah. Tengah, ini B, ini D. Darab B, darab D. Sama lah macam ni. Kalau you tengok in the formula, you boleh pilih sama ada you nak pakai density ataupun unit weight of liquid. You know that untuk tukar unit weight dia adalah density darab dengan gravity acceleration. Therefore, when you calculate, jawapan you akan sama je. A masonry dam of height 6 meter. The height of the dam is 6 meter. Retains water on its vertical face. Calculate the resultant hydrostatic thrust acting on a meter length of wall when the water level reach the top of the dam and the water level is 1.8 meter below the top of the dam. This is terus the answer. So we're going to lukis dulu. Okay, water retain at the back. The first question cakap the water at the back is sampai top of you punya retaining wall. You punya H akan jadi 6 meter. So this is our formula. Tadi kita dah tahu kan? P sama dengan, we have two formula which is half times PW G H darab H. Ataupun 1/2 darab unit weight H darab H. If you notice that formula yang I put here is this formula. Half times unit weight of water times H times H. So H power of 2 lah. Kita kena cari unit weight of water because the question yang dia bagi density. So density is PW. You can either use this formula or you can use this formula, but you need to convert from density into unit weight. The formula to get the unit weight from density is PW times dengan G. Kenapa I dividekan 1000 kat bawah ni? Because you're going to get the value in Newton. 1000 darab 9.81 you akan dapat this value. So unit dia akan jadi meter cube ni you abaikan kilogram meter per second kuasa 2. Okay, ini adalah sama dengan Newton. Per meter cube ni jangan kacau. Because this thing adalah dalam unit density. Density nak tukar pada unit weight. So 1000 kilogram ni je meter per cube abaikan because later on meter per cube ni kat bawah ni. So you just nak convert kilogram ni pergi Newton. So after you dah convert to Newton, so you need to convert it into kilonewton so that you dapat dalam kilonewton. Bagi just 1000 untuk jadikan dia kilonewton. So unit weight of water, put it inside the formula. 176.58. So kilonewton untuk setiap 1 meter. Maksud 1 meter tu setiap 1 meter. For example, retaining wall macam ni. So setiap 1 meter panjang retaining wall you ke sana lah. This is for A. And then we have for B. The water level is 1.8 meter below the top of the dam. 1.8 meter. This is 6 meter height retaining wall. The question state that the water level is 1.8 meter below the top of the retaining wall. Dah namanya liquid pressure. So of course lah height ni sebenarnya adalah height of liquid. Kalau liquid you sampai top, so that's why jadi 6 meter. 1.8 meter below the top of retaining wall. That's why 6 meter minus 1.8 meter. Sama juga use the same formula. So use the unit weight of water. Sebenarnya tak ada masalah kalau you pakai this formula, but don't forget to divide by 1000 because we need the value to be in kilonewton, bukan dalam newton. Okay, so masukkan je, so you akan dapat 86.524. Okay, again, another question. A masonry wall dam retain water on its vertical face. The wall is as shown in figure 3.7 meter, but water level reach only 0.7 meter from top of the wall. Let's say wall dia 3.7, water level dekat sini. What is the magnitude and the position of the resultant water per meter pressure run of wall? Dia minta magnitude and also minta position. Okay, position macam tadi, macam kita calculate dia kat mana the centroid of pressure distribution and the distance from the centroid to the bottom of the wall. Okay, macam kita kira wind pressure tadi. I use the same formula as the previous example. Unit weight of water memang 9.81. And density of water memang 1000 kg per meter cube. If let's say not given, you baca ada perkataan water kat sini, automatic you tahu unit weight dia 9.81 kilonewton per meter cube. Just put it here, 9.81 as a unit weight and then 3 meter. Okay, because of here already given that 3 meter. You dapat 44.145. And then position of the resultant truss, as I explained before, this is retaining wall. The pressure distribution going to be like this. Doesn't matter kalau you buat macam ni pun boleh. Okay, pressure distribution. Sebenarnya kat sini dia punya value adalah unit weight darab H. Maksudnya you kira area 1/2 times ni H darab dengan H. Dia punya height Macam mana you nak kira position of resultant truss? Where is the centroid? Biasa centroid mesti kat sini kan? So berapa value ni? Sebenarnya 1/3 darab H. Macam mana dapat sini? So kalau you ada segitiga, obviously kat sini ada centroid. Kat bawah ni biasa 1/3 sebab you tengok kat bawah ni area dia lebih besar. So centroid dia mesti lebih ke bawah. Kat atas ni area dia lebih kecil. So yang atas ni 2/3 lah. Sama juga kalau macam ni. 1/3, 2/3. 1/3 times H, height of liquid. It is 1 meter from the bottom of retaining wall. That is the position. Next is pressure due to retained soil and other granular material. Soil, unlike liquid, are not usually uniform. Differences properties from one layer to another. The whole layer of soil, bukan daripada top to bottom, jenis soil dia adalah sama. So, different properties. If quantity of each of such material was tipped on the flat surface, it would float out to form a conical heap. Let's say you ada soil, you genggam dengan tangan you and then you release the soil sikit. Dia akan jadi macam ni lah. Soil tu jatuh, dia akan naik jadi conical heap. A more reliable measure of internal friction of the soil is obtained by testing the soil in laboratory. Kenapa jadi macam ni? Because soil tu sendiri dia ada friction because of each particles dekat dalam soil tu. Dia ada different texture. Dia berlekuk-lekuk, bersegi-segi, different shape and texture. Dia akan provide friction resistance pada the soil itself. Because of dia ada surface resistance kan. There is a friction. How are you going to measure it? Not more reliable dekat dalam lab lah. But other several useful theories exist. However, it will be sufficient to consider Rankine's theory. We're going to use Rankine's theory untuk measure the friction yang produced by the surface of the soil. So ini adalah assumption daripada Rankine tadi. Materials is incompressible, homogeneous, satu jenis, granular, cohesionless. So bukan cohesive soil . This one lebih kurang pasir lah. Pasir is cohesionless soil. That possess internal friction resistant to movement between grains. If the quantity of such material was tipped into flat surface, it would form a conical heap. This is what I told you before. So dia akan jadi naik macam lah, conical heap. The material within the cone support itself due to internal friction because of other friction between the surface of each particles. The angle of side of cone is known as angle of repose. Ini namanya angle of repose ataupun angle of shearing resistance. Kita panggil as theta. Liquid do not possess internal resistance to shearing. The angle of shearing resistance for liquid is 0. Okay, so liquid tak ada angle of shearing resistance because if you pour liquid in bekas ke apa, it will actually ikut shape of that particular bekas. Jadi dia tak ada shearing resistance ataupun dia tak ada angle of repose. In frictional materials, the lateral pressure exerted somewhat less than the vertical pressure. In Rankine theory, the ratio between the lateral and vertical pressure is evaluated in terms of angle of shearing resistance. So Rankine theory of lateral pressure, this one for granular material ataupun soil lah. P is equal to half Ka unit weight H times H. So kalau you notice, formula lebih kurang sama, cuma ada additional Ka kat sini. Ka dekat sini adalah Rankine theory. So what is Ka? Ka ni tadi, you nak calculate the friction tadi tu. Maksudnya resistance to shearing tadi . You look at the formula here, 1 minus sin theta. Theta here meaning angle of shearing resistance ataupun angle of repose tadi. The unit weight here adalah unit weight of soil tu lah. Unit weight of granular material. H here means height of soil. For example, tanah sampai sini. This is the pressure distribution. Sama juga macam liquid. Dia segitiga uniformly in. Where is the centroid? The centroid going to be here. 1/3 times H. Kat sini juga dia punya pressure distribution centroid guys. Tadi I'm talking about the formula. This is value of Ka, unit weight darab dengan H. How you get the pressure? You kira area dia setengah because of this is triangle times Ka unit H darab dengan dia punya height lah. K darab H. Let's say dalam question dia tak bagi unit weight. Dia bagi density macam ni. So sama juga. This is density darab dengan gravity acceleration. So you boleh convert pada unit weight or you can calculate terus dalam ni pun boleh juga. But don't forget to divide by 1000 because you need to convert from Newton to kilonewton. Since the PA varies uniformly with depth of region, so the pressure distribution diagram for lateral pressure on AB is a triangle. We're going to look at example number 4. Soil weighing 15 kilonewton per meter cube. This is unit weight of soil. And having an angle of repose of 30 degrees. This is theta, angle of repose. Exerting pressure on 4.5 high vertical force. What is the resultant horizontal force per meter run of the wall? Memang tinggi soil tu 4.5 sama macam retaining wall itself. So this is H. The value of Ka first because this is to calculate the shearing resistance. Ka equal 1 minus sin theta plus 1 plus sin theta. Tadi formula tadi ya. Masukkan the value of 30 degrees as the angle of repose. Atau bila you kira ni, you dapat 0.5 over 1.5 if I'm not mistaken. So sama kan? Ataupun kalau you calculate directly, maksudnya you calculate, you tak buat dalam bentuk pecahan macam ni, you buat dalam bentuk decimal, so you dapat 0.333. We're going to calculate the pressure due to retained granular material. 1 over 2 times Ka times unit weight of soil times H. 1 over 2, Ka calculated 1 over 3, 15 the unit weight of soil, H is 4.5. The height of soil. I dapat 50.625. The next question is, a masonry wall with a vertical back 6 meter high retains earth having a density of 19. Here dia bagi density. And angle of shearing resistance of 30 degrees. This is theta. Calculate the active lateral thrust theory on the wall using Rankine's theory. You have to calculate the value of Ka. You nampak je perkataan soil, so mesti ada shearing resistance. You need Rankine theory. Here I convert lah from the density, I convert jadi unit weight. Darab dengan gravity acceleration divide by 1000 to convert Newton to kilonewton. Dapat 19.228 kilonewton per meter cube. Kita boleh masuk dalam formula. Let's say you terus nak pakai formula ni pun boleh. Tak kisah letak H kuasa 2 kat sini pun boleh, H sini pun boleh, nak siasat tak apa. Boleh juga you pakai formula ni. Okay. Ka, masukkan unit weight of soil yang you dapat kat atas ni, yang you convert daripada dia punya density times dengan height of soil. I dapat 115.368. Kadang-kadang you confuse kenapa tiba-tiba I tulis, kadang-kadang I tulis P, kadang-kadang I tulis PA. Sebenarnya maksud dia sama saja. PA here means active lateral thrust. Kenapa nama dia active lateral thrust? Because of retaining wall macam ni kan. Sebenarnya dia ada dua, satu passive, satu active. Yang dekat belakang ni kita panggil active. Kalau kat depan ni kita panggil dia passive. Because of help to stabilize you punya retaining wall. Dia duduk kat depan ni, so dia help to push, to stabilize the retaining wall. This one nak push it out. This one akan push it inside back. Macam tu lah. So this is passive. Sometimes you nampak itu active kat sini. Normally this is active lah. Because we only learn pasal active lateral thrust sahaja. Saya masuk pada step wall faces. So sebenarnya kalau retaining wall you macam ni ke, step dia dekat bahagian yang you retain ya. Kat sini ada retain material. Remember ini A, ini B. This is toe, this is heel. Heel mesti dekat belakang. The lateral pressure is assumed to be abnormal to the supporting structure. Therefore, the direction of this pressure will be horizontal. Sama je. Macam mana you kira for the yang wall yang I tunjuk. Contoh straight kan. Doesn't matter the step sekalipun. Here we have inclined wall faces. Okay, but don't confuse. Kenapa macam ni? Okay, so sebenarnya ini A, ini B. Kita balik dia lukis. Ini heel kat sini. Because of retained material is at heel. Material akan duduk behind the heel side of retaining wall. So ini bahagian front side dia. Ini belakang ya. This is L. The formula is P pressure is equal to half times PA times L. PA here, you nampak kat sini dia tulis small p. Small p is not density Sebenarnya tadi kalau you perasan, value ni KAH adalah small p. Ini adalah pressure juga. Pressure at that point. Pressure at this point. Kita nak kira total pressure untuk tinggi ni. Betul. We need the value of pressure at the point yang paling tinggi, which is yang dekat bawah sekali untuk calculate area dia. This is small p. Okay, sama juga. Kalau liquid tadi, formula dia 1/2 darab unit weight of water darab H kuasa 2 kan. Ataupun setengah 1/2 darab unit weight of water H darab H. Ini adalah small p. Ini semua adalah p besar. This is for liquid pressure. In the inclined wall faces, so P tu adalah that small p. Okay, small p sama dengan, let's say it retain water. Kalau retain water, unit weight of water darab dengan H. This is for liquid. And if it retain soil, small p dia adalah, kalau you kira the big P, maksudnya the total pressure dekat semua tu, pressure distribution semua tu, kira area dia kan, setengah darab unit weight water H. So darab dengan, you nampak kat sini PA darab dengan L. L ni adalah sloping height. So maksudnya mana? Ini. Okay, so condong ni, panjang condong ni berapa? Darab dengan L. Sama juga big P for this is setengah darab KA for sol darab H darab dengan L juga. Effect of surcharge. Okay, when the superimposed pressure is applied at the surface of the retained soil, the active lateral pressure is increased by the proportional amount. Superimposed pressure ni apa maksud dia? You have a retaining wall here. Contohnya belakang ni is soil. So you pun binalah satu bangunan kat sini. This bangunan adalah surcharge. Beban tambahan, extra. This is superimposed pressure. Kalau setakat orang seorang berdiri kat sini, kita tak anggap dia superimpose. Berapa sangatlah loading daripada this particular person compared to a building. Symbol for surcharge is PAS. Sama juga masih lagi pakai KA. Okay, kenapa KA? Because of surcharge only ada dekat soil, retain granular material. Surcharge tak ada dekat water. Water is not like soil. Soil dia, let's say you put anything on top of the soil, dia soil tu akan mampat kan, how to say. Kalau water dia akan melimpah dia keluar. Kalau you letak boat tu akan float. Dia bukan terus masuk ke dalam, tenggelam dan menjadi satu yang mengganggu dia punya loading kat situ. Ini only effect pada tanah saja. So KA times Q. Q ni is surcharge pressure and then times dengan H. H ni height of soil. The total of overturning moment is the sum of moment of PA and PAS. If you nanti you kira overturning moment, you kena kira moment that caused by the pressure due to the soil itself, and then let's say there is a surcharge ataupun superimposed pressure, you must include it masa kira overturning moment. So determine the active lateral thrust acting on a retaining wall described in example 5. If there is also a surcharge of 20 kN per meter square acting on the surface of the soil. This is the solution. It's according to the example 5 because dia bagi surcharge, dia minta total active lateral thrust. Maksudnya termasuk juga dengan surcharge. Pressure due to soil that kita dah kira example 5. Sekarang kita kena kira surcharge so that kita dapat total active lateral thrust. We already calculated before. KA we know that it is 1/3 according to example 5. We look at example number 5. Kat sini kita dah kira tadi example number 5. We already calculated that KA equal to 1/3. This is value of KA. And then Q given in the question, the surcharge is 20 kN over meter square. This is unit of surcharge. Untuk 1 meter square is 20 kN. And then H, according to the question, example number 5, you know that the H is 6 meter. You dapat total of surcharge is 40 kN per meter. Okay, the total pressure, active lateral thrust dia, plus dengan surcharge. This is according to example number 5, 115.368. So nampak sini 115.368. Ni value of PA plus dengan surcharge. So you dapat total active lateral thrust. I'm going to wrap up this. So we finish it here. Have a good day everyone. Bye. Assalamualaikum.